Hey guys, so I've had many requests about an overclocking guide and the settings I'm using for my overclocked i7 30K. So I finally decided to do a video about it, talking a little bit about my settings and how to overclock stable. But it actually depends on your chip, your motherboard, and your cooling, of course. So every chip varies and overclocks differently. So first, let's take a look at the AI overclock tuner. I've set this to XMP. You can set it to manual if you know the timings for your RAM and all the settings, the voltages and stuff. So you can set them manually. I do know them, but I decided to go with XMP because it's easier and you can adjust, of course. You can just set it to XMP and then adjust the voltages and stuff yourself. So like go slightly higher or anything if needed. CPU level up, disabled, you don't need that. Yeah, this is the XMP profile and the base clock frequency. I haven't messed with that. Some people actually change it, but I don't because that's not needed with the second and third generation processors or Core i7 processors. The CPU strap is set to auto, clock channel reset enabled. Um, yeah, and turbo ratio is set to by all cores. You can set it to by per core if you want different frequencies for all 6 cores. But for me, I recommend just using one frequency for all cores because I haven't actually tried using different frequencies for different cores. So, and the clock jump filter is set to auto as well. Now your memory frequency, it's set by XMP in my case, and yeah, I have 2133 megahertz Corsair Dominator. So if you're using manual, then you can just set it yourself or use XFP and let it set it for you. Extreme tweaking disabled. If you power saving mode disabled. You only yeah, you don't need extreme tweaking, but it could improve some benchmarks and stuff. But I haven't tried it. Now, DRAM timing. Here, you would want to set the if you have a Rampage motherboard, then you might want to set this to mode 2 because mode 2 helps overclocking performance, and due to Intel's specifications, then RAM is overclocked over well, if you're running it over past 1333 megahertz, I believe, or 1600 in some CPUs, or I think in Ivy Bridge. And yeah, now the gas latency. This is your latency, your primary timings. Um, so we have the latency, RAS to CAS, delay, RAS pre-time, act time, command mode, and latency boundary. If you set again, if you set XMP, all this will be adjusted for you automatically. I've gone and edited some stuff here, so it might improve some stability issues, but I don't recommend doing anything here because XMP sets everything for you. And in case you want to adjust stuff yourself, then you can. There are many long guides on the internet, so you can find any and just do it. But RAM is not really something that's very important when it comes to CPU overclocking, although it does affect performance depending on the frequency you're using. The lower the frequency is, the lower CPU voltage you will need. And yeah, the more stable it will be. So Digi Plus power. This is quite important for the CPU. Now the load line calibration, I've set it to medium for gaming and normal use, programming, editing videos and all that. You don't need to use higher than medium. But if you're I don't really know the difference between, like, why would you use high instead of medium, but if you use high, then the voltage of your CPU will have more space, or like it could go up more than if you use medium. So if you have very good cooling and you don't care if your voltage goes up a little bit higher, then you can use high. And the current capability is, I've set it to 120. You can set it to between 110 or between 120 to 140. But if you set it to higher than 120, in my case, I can't adjust the CPU power phase control. It is set automatically to extreme, and that is not what I want. I want the power phase control to be set to optimized. So that's why I set it to 120. I believe in some other motherboards you could actually go past 120 and still be able to set this to optimized, but you have to experiment with this yourselves. And the voltage frequency set to auto, temperature protection auto, duty control T probe, mass voltage control auto. Yeah, now here comes the CPU VSA. The VCCSA load line calibration is set to regular in my case, and I don't recommend going for high or extreme unless you're like only benchmarking or using extreme coolings. Current capability is set to 120, just like the CPU load line calibration. Yeah, 120. Past that, I haven't gone past that, and I don't think it's needed actually. Fixed frequency, I haven't messed with that. We see boot up voltage, no auto. And VTT switching frequency set to auto. Overcurrent protection, you have to enable this. Now the DRAM voltage, you will have to give it some extra percentage here, so gone from 100 to 120 on all channels, so both channels A, B, and C and D, set to 120%. Don't mess with the voltage frequency, just leave it at auto. Power phase control set to optimized for best performance and stability. Now CPU performance settings. Here you don't need to adjust anything, but some people don't need a speed step, and therefore some people disable it. Just for, I don't know, it's up to every person, and if you want your CPU to run at constant voltages and constant frequencies the whole time without shifting between, or without underclocking itself, when ideal. But I do recommend using these settings so that its CPU rests when you're not using it, or when you're not stressing it. Now here we have the GPU DIMM post. I haven't messed with that. You don't need to do anything here. Extreme OV disabled. Now the base clock's Q. I've read that the best setting for this is -2, and if you go to CPU Tweaker's Paradise, you will see that the PCI clock skew is set to -20. So that's I read that that's a good setting to set this to -20, and the base clock skew to -2. You can experiment with that if you want, but I just did like the guide said. Now here comes the CPU V-core voltage. There is two options here. You can either do offset or manual. If you do manual, then you'll have to set the voltage yourself and experiment depending on your clock and how high you're gonna overclock. In my case it's 4.6 and I'm using offset, and my offset voltage is up by 0.040, which makes it go up by or to about 1.3 1.39 or 38 millivolts or volts when it's on load. And the more you give it, the more you can overclock. But with manual, if you're using manual voltage, then the CPU voltage won't decrease when you're using the CPU, or when you're not using the CPU, when you're not stressing it, which would actually reduce the lifespan of your CPU, I believe. I have used manual before, but then I switched to offset because I thought it was much more reliable. But you could use manual or offset, and you have to experiment with these offset voltages yourself. For me, for 4.6, I'm using 0.040, and it gives it's basically calculation, but it's not like adding 0.040 to your actual voltage, because that's not much. It actually adds more in Windows, not in BIOS. So you need to look up your voltage in Windows, not in BIOS, when you stress test. And if you set manual, then it's much easier. You can just set, in this case, if you want 4.6, then you can set it at maybe 1.38 or 1.39. In some cases 1.4 is required, depending on your RAM and on your RAM frequency and all that. But yeah, the higher you go, the more voltage you need. So if you go, for example, 4.7, 4.8, then you will need at least 1.43 on the V-core. And for less than 4.6, then try using 1.35, 1.36 and experiment yourself. Go use high voltage, like 1.38 if you're using 4.4 gigahertz or so, and then test if it's stable, go down a little bit. Test if it's still stable, go down until it's not stable, then up the voltage where it was stable, like the test before. It's quite easy. So if you set it like 1.38, let's say, then test stable, set to 1.37 stable, 1.36 stable. Then if you set it to 1.35, for example, it's not stable, then just go up it to 1.36 again, and you're done. Same thing goes with all CPU frequencies. Now VTT CPU voltage, I've set it to 1.15, and I believe it shouldn't be, the difference between this voltage and your CPU voltage shouldn't be more than 0.5 volts. So make sure that the difference is not more than 0.5 volts. Second VTT CPU voltage, I set it to 1.05099. This is not really, you don't need to mess with that, but for extra stability you could set it to 1 point something, 1.1 or 1.05 in my case. The VCCSA, I've set it to manual. You can also use offset here, but I haven't used offset, I use manual. And I've set it to 1.15 because it should be close, relatively close to the VTT. And also 0.5, not more than 0.5 difference than the V core, as I remember. The DRAM voltage, you have channel A and channel B, C, and D. The default for my sticks is 1.50, but I have upped it a little bit to 1.51 just to be extra safe in case it needs more voltage. You can do that as well. If some RAMs run at 1.65, you can up them to 1.66 if you want, just to be extra safe. But then Intel doesn't recommend going past 1.65, so you should experiment with that yourselves. The PLL voltage, I've set it to 1.8 as it's the recommended voltage for this CPU and setting. I haven't messed with the PCH, VTD, DDR. You don't need these if your RAM is unstable, then you could try to put some voltage here to help your RAM stability. And when it comes to spread spectrum, CPU and PCI, you need to disable these two. Tweakers paradise, as said before, the PCI clock skew is set to -20 in my case. Memory tweakers, I haven't messed with all these three. You don't need to. Now going to CPU configuration. Here you have the CPU configuration settings. Intel adaptive thermal monitor. This is disabled. You don't need this. And I really don't know what it does. You need hyper-threading. You need all processor cores. CPU ID maximum is disabled by default. Keep it disabled. The disabled bit is disabled. Hardware prefetcher enabled. Cache line prefetch enabled. DCU streamer prefetcher enabled. DCU IP prefetcher enabled. And the virtualization is enabled as well. And yeah, I recommend using these settings as I'm using in my case. The power management for the best performance and power saving, then make sure that C1E is enabled. I have disabled to C3, C6, and C7 as they're not really that important. But C1E is enabled if you want power saving and your CPU frequency to dip down when you're not using it or when it's not on load. And the speed step and turbo mode, as said before, they are needed. In my case, it's up to every person to decide if they want turbo and speed step, depending on their use. Now, everything else here is not CPU related. When it comes to anti-surge support, make sure to disable that. We don't want that. I don't really remember what it was for, but JJ explained from ASUS explained that it should be disabled because it will make your system, I believe, unstable, or yeah, you should disable it as soon as you overclock your CPU. That's all you need to know. But if you want to know more, then you can just Google it or search, do some research. Voltage monitor, we don't have anything left for the CPU. And yeah, one last thing is you can go ahead after doing all these settings. You can go ahead and save them to different profiles, and so that you don't have to do everything over again if you're going up or down in your CPU and your voltage and your your voltage or frequency. You can just load the profile and then adjust the voltage depending on your frequency. So yeah, it's mostly about the V core. The higher you go, the more V core you will need, and you will need to test yourselves and see for yourselves. So as soon as it's stable, you just use the least voltage you can use but it should still be stable. And the best way to test this is with the Prime 95 large FFTs. Test for at least 1 hour and see. Temperatures are also important, so don't let it go past 80 Celsius is my recommendation. Or actually, I don't let it go past 70. So yeah, but it's up to every person and how long you want your CPU to live. And yeah, I hope this quick guide helped a little bit. And yes, thanks for watching.